Let's learn about linear equations that have two variables in them. We already talked about first degree or linear equations that have one unknown, something like 2x plus 3 equals 10. That will be a first degree or linear equation, and we know we can solve this by isolating for x and solving for x and finding out what x is. But now we want to take a step further and talk about linear equations that have two variables. Instead of just one unknown, there are two unknowns in them. So one, we can call it x. So imagine 2 times x plus 3. Now minus another variable, y, for example. It could be any letter, does not matter. These are just labels. X and y are labels. 2x plus 3 minus y equals 10. Now this is still a linear equation because the greatest exponents of the unknowns here are 1. So it qualifies as a first degree or linear equation, but it has two variables. Now why do I call it variable? I don't say unknown because unlike when we had one unknown in the linear equation, when you have more than one unknown, now there is no one single solution. There's no one fixed answer to the unknown. So the values of the unknowns could vary now depending on one another's values. So since they vary, these are now the type of unknowns that we call variables. Okay, let's see what do we mean by their values is varying. So in here, we can give certain values to x and y and find the other. What do I mean by that? Imagine we can make a table. So in the first column we have x, in the second column we have y. Imagine I give the value of 0 to x. So I have to substitute x as 0. Let's go ahead and do that. So 2 times 0 plus 3 minus, what is y? We don't know. We put y for now. We want to find out what y would be if x is 0. And let me make that 0 green so you know I substituted x as 0. 2 times 0 plus 3 minus y equals 10. Great. So now it turned into, from a linear equation with two variables, now it turned into a linear equation with just one unknown. Now we can go ahead and solve for y, because if I simplify this equation, 2 times 0, that's just 0. So it's just 3 minus y equals 10. Now how do we solve this? We already have seen that process. We need to isolate y on one side. So we need to remove everything else. Right now there is a 3 on the left hand side. So I'm going to subtract 3 from both sides of this equation to get rid of that 3 on the left hand side, so we can one step more make y isolated. So that has 3 minus y minus 3 equals 10. Also doing it to the right hand side, minus 3. Great. So we can see this 3 cancels with this 3 on the left hand side, and we have just negative y on the left hand side equals 10 minus 3 on the right hand side. 10 minus 3, that's 7. So negative y equals 7. Are we done? Is y isolated? No. We still need to get rid of that negative sign. So how do I get rid of that? How about multiplying both sides by negative 1. Negative times negative is positive. So I'm going to multiply negative 1 by negative y on the left hand side, and I do the same to the right hand side. 7 times 7 multiplied by negative 1. Okay, negative times negative y equals positive y. We do it with red. Equals 7 times negative 1, that's negative 7. So when x equals 0, y equals negative 7. You see what happened? We substituted x with 0. Why? You may ask, why did you give 0 to x? Well, we can give any number. These are variables. They can vary. You can give any number to x and find out what y will be. Literally anything you want. You can substitute x with 1, with 2, with negative 1, negative 2, 1,000, a million. And then you solve this equation and find what y will be for that x. Their values depend on each other. Now, for example, I can give, instead of 0 to x, I can give 0 to y and find out what should be x if y is 0. We can do that. So let's actually do that. I'm going to delete these. Oops, I deleted the original equation. All right. So we had 2x plus 3 minus y equals 10. Now we want to substitute y as 0. So let's go ahead and do that. 2 times x plus 3 minus 0 equals 10. Great. Now that will simplify as just 3 minus 0 is just nothing. So we can rewrite the equation as 2x plus 3 equals 10. That's it. Now we have to solve for x. Now this is a normal linear equation with one unknown. We know how to solve this. Isolate x. So what is bothering us is this 3. Why I deal with 3 first and not with the 2 that is multiplied by x? Because if I deal with 2, that's a bit more, makes it more difficult, but you can do that too. I can do that this time so you see it. So I can first divide both sides by 2 so that 2x divided by 2 will become 1x. So let's see what happens if I divide both sides by 2. You will see. Divide both sides by 2. So on the left hand side I have 2x plus 3. I have to divide it by 2. That means I have to divide the entire left hand side by 2. Be careful. You cannot just do that to the 2x. So dividing the entire left hand side by 2 and dividing the entire right hand side, which is just 10, by 2. That's great. Let's see what do we get. So the left hand side turns into 2 fraction, 2x divided by 2, that's 1, and then plus 3 divided by 2. As I said, you have to divide the entire left hand side by 2. That is comprised of 2x and 3. So we divide both of them by 2. That's the left hand side, equals 10 divided by 2. That's just 5. Nice. Now this 2 cancels with these 2. 2x divided by 2, that's just 1. So we write x plus 3 divided by 2. What is that? That is 1.5. And then equals 5. Excellent. Now in the next step, we can just what to do to isolate x? There's this 1.5 added to x. So we subtract both sides by 1.5. So we say x plus 1.5 minus 1.5 equals 5 minus 1.5. So 1.5 cancels with 1.5. That's just 0. So x equals 5 minus 1.5. That's 3.5. That's it. So when y is 0, x is 3.5. You see? And you can continue doing this ping pong. Basically, give a value to x, find the value of y. Or give a value to y, find the value of x. Infinitely. You can give any numbers to them. And basically, unlike linear equations with unknowns, here there are two variables, so they can assume a whole domain of numbers, or a whole range of numbers could be their answers. We can even visualize their answers. We can graph them. So let's do that. So here is, I have drawn a two-dimensional graph. So we can label these, for example, this axis, we can call it x. And this axis, we can call it y. Or you could do in reverse, does not matter. We can just do it, we set it up in this way, as long as you visualize it any way you want. Because we're not following any standard yet. We're just doing it on our own, so we can set up this visualization any way we want. X, this axis, y is that axis. Where these two axes are meeting at this, right at the center here, this is basically, this center is 0. That x is 0 at there, y is 0 at that point as well. So as you go to the right side, you go to positive values. So this is, for example, is positive 1. This is positive 2, 3, and so on. These are negative values. So negative 1, negative 2, negative 3, negative 4. And the same thing for y. Y is positive when it goes up. So this is positive 1, positive 2, positive 3, positive 4. And when you go down, it's negative. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. So that's how our visualization is set up, with two axes, one as x, one as y. Now, these points that we have figured out from the equation, we can find them on this graph. So the first point is 0, x is 0, and y is negative 7. So like a chessboard, I go to that point. So x should be 0, so x is like right on the center here. X should be 0, y should be negative 7. So y negative 7 is here. We're looking at this point, basically. This is, let's call it point 1. So this is point 1, basically. What is the other point? Let's find the other point. 3.5 is x, and 0 is y. So 0 is the center for y. 3.5 is on the x-axis. So this is positive 2, positive 3, positive 4. So right in between 3 and 4 on the x-axis is point number 2. That is point number 2. That's it. We found these 2 points. And if you give more points to the equation to find more values for x and the corresponding values for y, you will find more points of this graph. But since this is a linear equation, we know it's linear because the greatest power of the unknowns are 1. So we know the visualization of this graph is going to be just like a line. So I can And a line, you can draw a line if you just have 2 points from it. You can exactly draw that line by connecting those 2 points. And guess what? Here we have 2 points from this graph, 0 and -7, 3.5 and 0. And if I connect these two, I have visualized all the values in between them, basically. Right? I can even extrapolate. I can even go beyond this and go even here below, extrapolate, because we are sure this linear equation is going to continue linearly. So it's a straight line. So for example, at x equals 5, which means over here x equals 5, you can find out what y will be just by drawing a line going perpendicular to the x-axis until you reach the graph's line, and then going perpendicularly to the y-axis to find out at that point what y will be. Y will be 3. When x is 5, y will be 3. You can go ahead and actually investigate that. Like plug in x as 5 and see if you get y as 3, or do the reverse. Plug in y as 3 and see if you get x as 5. You should get that answer. So that's kind of allows us to predict different values from this equation. And that's the power of variables in these equations. That's basically how weather is predicted, or any other thing. Stock market, you just have different variables and a different equation. The equation could look different, more complicated. It would, for example, for predicting the weather, you could have a lot more variables, like the temperature, the wind, the humidity, etc., etc. So in here we just had 2 variables. It was a linear equation, very simple. And this is basically the application of linear equations with 2 variables. And we actually visualized them. Hope you enjoyed it. Let me know if you have any questions.